Have you heard of James Clerk Maxwell? He is regarded as one of the greatest theoretical physicists of the 19th century, and for good reason. He successfully formulated a complete electromagnetic theory, represented today by what is known as Maxwell's equations. But what are these equations, and why were they controversial at the time of their development? In order to come up with these equations, Maxwell had to bring together the work that had been done by physicists such as Ørsted, Coulomb, Gauss, and Faraday, and add his own science. The equations are separated in 4 groups. The first equation consists of a special form of Coulomb's law, known as Gauss's law for electricity. It dictates that electric field lines originate on positive charges and end on negative charges. The second of Maxwell's equations is known as Gauss's law for magnetism. It dictates that magnetic field lines are continuous with no beginning or end. The third equation is Faraday's law of induction, and it includes Lenz's law. It dictates that a changing magnetic field induces an electromotive force where the direction of the force opposes the change. The fourth equation encompasses Ampere's law and dictates that magnetic fields are generated by moving charges or by changing electric fields. Maxwell's work, as ingenious as it was also extremely controversial at the time. In 1865, Maxwell suggested that visible light is an electromagnetic wave. The physicist came to this conclusion by noticing that the speed of propagation of electromagnetic waves was very close to the speed of light, writing at the time, "This velocity is so nearly that of light that it seems we have strong reason to conclude that light itself, including radiant heat and other radiations if any, is an electromagnetic disturbance in the form of waves propagated through the electromagnetic field according to electromagnetic laws." This suggestion elegantly unified the fields of electromagnetism and optics. However, it also upended the traditional Newtonian conception of the world, which was based on particle interactions, by pointing out the vital role of waves in physics. Many vehemently fought against Maxwell's ideas as a result. It was not until 1886, 2 decades later, when German physicist Heinrich Hertz generated electromagnetic waves in a laboratory, that the accuracy of Maxwell's equation came to light. Hertz verified the wave character of the electromagnetic waves he generated and was able to determine wavelength from the interference patterns. He was then able to calculate the propagation speed using the equation wavelength equals frequency, demonstrating once and for all that electromagnetic waves travel at the speed of light. Still, despite his work, it was only in the 1890s that Maxwell's equations saw practical application. Through the work of physicist George Francis Fitzgerald and others, Italian engineer Guglielmo Marconi began experimenting with wireless telegraphy using Maxwell's equations.